Hi, in this session, we'll discuss the steps involved in hypothesis testing. Data analysis in general can be classified as exploratory data analysis or confirmatory data analysis. In exploratory data analysis, the idea is to look for new or previously unknown hypotheses or suggest hypotheses. In case of confirmatory data analysis, the objective is to test the validity of a hypothesis or confirm whether a hypothesis is true or not using techniques such as hypothesis testing and regression. Hypothesis testing can be classified as parametric hypothesis testing, in which the test is about a population parameter, and non-parametric hypothesis testing, in which the test is about other characteristics such as distribution of the data and so on. The following steps are used in hypothesis testing. The first step is to describe the hypothesis in words. A hypothesis is described using a population parameter in case of parametric testing, and the population parameters are mean, standard deviation, proportion and so on, about which a claim or hypothesis has been made. A few examples of hypothesis are: the average time spent by women using social media is greater than that spent by men. On average, women upload more photos on social media than men. Customers of mobile phone service providers with more than one mobile handsets are more likely to churn. The mortality rate of the coronavirus is independent of certain population characteristics such as gender. Let us look at the second step in hypothesis testing. Based on the claim made in the step 1, we define null and alternative hypothesis. Initially, we believe that the null hypothesis is true. In general, null hypothesis means there is no relationship between two variables under consideration. For example, null hypothesis for the claim women use social media more than men will be there is no relationship between gender and the average time spent in social media. Null and alternative hypotheses are defined using population parameter if it is a parametric testing. The third step is to identify the test statistic to be used for collecting evidence against null hypothesis. Test statistic is a standardized difference between the null hypothesis value and the observed value. Test statistic will enable us to calculate the evidence against the null hypothesis using probability value, in short known as p-value. The test statistic will depend on the probability distribution of the sampling distribution. For example, if the test is about population mean value and the mean is calculated from a large sample with a known population standard deviation, then the sampling distribution will be a normal distribution and the test statistic will be a Z statistic, that is, it follows a standard normal distribution. The fourth step is to decide the criteria for rejection and retention of null hypothesis. This is called significance value, traditionally denoted using the symbol alpha. The value of alpha will depend on the context. Usually, alpha is taken as 0.1, 0.05 and 0.01. The significance value alpha corresponds to the maximum allowable value of type 1 error. We will discuss type 1 error later. The fifth step is to calculate the p-value or probability value, which is the conditional probability of observing a test statistic value as extreme as the one observed in the sample given the null hypothesis is true. In simple term, p-value is the evidence against null hypothesis. A small p-value, say less than 0.05, indicates significant evidence against the null hypothesis. In other words, the evidence is strongly against null hypothesis. P-value was proposed by Fisher as an index that can be used to decide the strength of evidence against null hypothesis. P-value is often misused and misunderstood concept in statistical inference. We would like to provide the following definition for p-value. According to Fisher, p-value represents the probability of obtaining an effect size equal to or more extreme than the one observed in the data considering the null hypothesis is true. P-value thus provides quantitative strength of evidence against the null hypothesis. According to Bio, the effect can be a measurement of difference between two groups or any measure of association between two variables. The sixth step is to take a decision to reject or retain the null hypothesis based on the p-value and the significance value alpha. The null hypothesis is rejected when the p-value is less than alpha, and it is retained when p-value is greater than or equal to alpha.